So do you want me to ask questions about the trigonometry or today's class?
Yeah, you can. If you've got something on trig, it's open for you. If you've got something today's class that you want to be prioritized, it's open for you. Yes.
Okay, now I'm fine with the trigonometry for now.
Yes.
I just want to know with the calculus,
Yes, yes.
how do I differentiate when they are trig functions?
Okay, when they are trig functions, that's what you
Yes,
wanted. Okay, I did see that particular question. And then
yes.
with this part, let me just check. Let me come here, and then I'll ask you to say, is there similar questions that you feel that they are asking? Just look at. Can you see my screen?
Yes, I can see your screen.
Okay. Now look at a few questions here that you can be looking for, and then maybe you can ask me from there. Is there something similar that you think? And then
4.4.
question
4.4.
question 4.4. Okay, let's look
Yes.
into that one. Then let me look at the other one here. If you see a similar question, also tell me here.
And
Okay,
then 2.5 as well, please.
and 2.5 as well.
Yes.
Okay. All right. So let's look into this now. Question 4.4. As you're saying,
Yes.
how do you differentiate with when it's trig functions? Am I right?
Yes.
All
Yes.
right. Now, the first thing I think we did talk about, I think if I go back to the previous lesson, let me take this in, was this formula, the formula sheet. Ne?
Yes.
Now, I hope you have it also near with you.
I have it on
Yes.
my other
Okay.
on a question paper I
Question paper,
downloaded.
yeah. So this is the thing. That's the first part to say. Whenever we okay, let's start with this part to say when you're given this formula, these formulas now, are you well acquainted or are you fine with these rules of differentiation?
That's I only need to go through them again.
Okay, so this one, what do we call this one?
I think that's no, it's not the chain rule, is it?
Is not. It's the product rule.
The product rule, yes.
Okay, so this is the product rule. That's right there. And then what about
Okay.
this one?
See, I need to go through this
Yes, you are
again.
right. It is the quotient rule.
The quotient rule. Okay.
Okay. And then this one, you just say it the first time. You say it is the what? It's the
The chain
chain.
rule.
The chain rule. All right. So now everything you're doing, you have to familiarize yourself here, as well as there's lots of information when it comes to here, this table, so
Yes.
that most of the things that you have, it's either they will give you something that is straight away that you can just use, you don't have to think about it, you have to just use from what they're given. If y, for example, if y is cosec x, dy over dx is that, it's already given, you don't have to prove it because the
Okay.
proof is not required. You can
Okay.
just, they allow you to just state it. So
Okay.
now, if we are given, let me say, this is the question here, question 4.4 here.
Yes.
It says differentiate with respect to x. So I'm going to be taking it one at a time, because if you are differentiating this, you can also write it down on your side there, so long.
Okay. Thank you.
Yeah, given y is equal to 1 over cosec 3x minus 1 over, let me just erase this, cot x plus square root of 2 over e to the power negative x, and then minus 6 to the power of 2x plus 2 pi over p. Alright, have you written it on your side?
Yes. I
Ah,
just want to ask a question.
yes, yes, yes.
When they give you the pi in the question paper,
Mm-hmm.
do you use it as is or do they tell you what's the value of pi?
When they give you pi, you use mainly the value from the calculator
Okay.
as is. So if you've got the value for pi from the calculator, is
Yes.
that one that you use. But I'll show you
Okay.
something now when it comes to that. Okay, let's just actually finalize this part. If I'm going to remember when I'm differentiating here, if I say dy over dx, Nicole, now dy over dx simple means change in y over change in x, right?
Yes.
And then what do you think is the dy over dx of that?
Well, there is not a y or an x.
So it becomes simple what?
The zero.
Thank you. This becomes simple as 0. So that's all.
Okay.
So it's not even going to play any role. But the fact that you say 0, you're just going to get a mark for that. Don't forget. All right.
Okay.
And then let's look at the other one now. If I'm given this one, let's take it one at a time. If I'm given dy over dx, let me do it one at a time. If it was y is equal to 1 over cosec 3x, right? So now, what do you think? How do we go about differentiating? Remember, we're given here a what? We're given here a 1 over. And if you're given a 1 over, you can't differentiate things at the bottom, remember?
So we need to bring it up.
Yes, I need to bring it up. So if I'm bringing it up, it becomes what?
A
This will be what?
cosec.
Cosec becomes what?
Doesn't it become white? Why is cosec now again? It's
Cosec is sine, remember?
yes,
Cosec
sine.
is sine. So this 1 over cosec x is the same as sine 3x. You see?
Yes.
So that is the first part that we needed to do that. To say we must remind ourselves, cosec is as long as it's a reciprocal of it's a reciprocal of sine, it's cosec, and then you can go back to sine. You know, you can play it around. Now,
Yes.
if I say here dy over dx of this, what do you think it will be of sin 3x? Now, you have two things now to do this one, Nicole. You can go straight to the answer, but it comes back from saying, if I say y, okay, let's start with the rules. If I say here, let just wait. If I say let 3x, let u is equal to 3x.
Yes.
Right. So now, what will it be? What will be our y?
The answer will be 3 because you need to multiply by 1 and then you need to subtract 1. So your answer will be 3.
Will be 3, right? And then, so which means in this case, what will be our y? Y is equal to sin what? Sin
3.
u. Are you saying
Then you need to put the u there.
the
Okay.
u there? So here, if I say then du over dx, let me take this down. If I say du over dx, what will it be? You just did it. You said it will be what?
It will be 3.
It will be 3. And then here, if I say dy, this is your chain rule, remember? Dy
Yes.
over du, what will it give me?
Sine u.
Sine u. So sine becomes what? You come back to the, remember I say you don't need to now to cram this. You see, sin x
Oh, it
simple
becomes
cos.
Okay.
Please rely on this table. You don't have to think and say I need to know it by head. You don't have to. That's why they brought it all here. Okay. So
Okay.
now the sign becomes cos. So if I come here, I'll be having now dy over dx is cos u, right?
Yes.
Now if I use the chain rule, how will I use the chain rule here? It will be what? Dy. I'm taking it back here to say dy over dx is dy over what?
The
Du
yes.
times du over dx. We're back to
Okay.
this. We're back to this one. The chain
Yes.
rule here. Dy over dx is dy over du times du over dx. Are you with me?
Yes.
And
Yes,
then
I'm with you.
from there, how do we find dy over dx now? It will be what?
You just fill in the values that you
That you
worked
get.
out.
Yes. So now dy over du, it was cos u
Yes.
times du over dx is what?
3.
Is 3. So now the answer then becomes 3 because we have to start with 3 cos our u is what? Our u is 3x. So it's 3
Yes.
cos 3x. But now, if you look at this, Nicole, it was not really worth going through this stage because someone can come back straight away here and say, if you give me y is equal to sin 3x, then if I say dy over dx, I know first of all I need to differentiate that. Then I
Yes.
get my 3 in terms of x. And then after
Yes.
that, I need to differentiate without the 3. I just want to find out what is dy over dx of sin x. Which is
So
what?
you get
Which is
cos.
cos. Then I maintain my what? My 3x.
3x your u.
Are you understanding
Okay.
me?
Yes, I understand.
So you don't have to every time go through this whole step. You're more like wasting time here because the answer, yes, you still get your marks. I'm not saying you're not going to get your marks, but you are making it too long, because
Yes.
you can literally see the answer that is going to be 3 3 will go out, and then the sine x becomes cos, but you maintain your 3x.
Yes.
Are you with me there? So
Yes, I'm with you.
that is that part. So it's one of the things that we are trying to find out. Am I right?
Yes.
And then let's look at the other one. What about this one? If I say minus is 1 over cot x, we'll put everything together as the final answer. But once we're getting these answers, you know that's what we're going to be getting. So we have done this one, right?
Yes.
So what about this one?
So we
We can
first of
forget about the
all,
negative for now. So
okay.
what are you going to have if you're given y is equal to 1 over cot x?
Yes.
Yeah.
So we need to take the chord up, so it's going to be tan.
Thank you, 10x. Then you come back to say dy over dx is equal to, look, I come back to the formulas. What is 10?
Sec squared
You
x.
see. So it's to me this one is a bit lighter to say.
Yes.
Sometimes I know there are some that we're gonna do though that can be a bit tricky. Sec squared x. You see that?
Okay.
And then we are done.
Just one more question.
Yes.
When they give you a question like this, how
Yes.
do you know when you need to use your chain rule or product rule?
Okay, let me, for example, look at something like, let me check here what we have. Okay, let's look at this. You see this one?
Mm.
Minus 6 to the power 2x. Now,
Yes.
you will see how it leads you automatically to say it's y is equal to 6 to the power negative 2x. I'll show you now to say what makes you in a way find that you are in a position that you can't just first of all differentiate it, or you have to use, as you say, the chain rule, or you have to use the quotient rule, or you have to use the product rule.
Yes.
Right. So from here, if I have to differentiate this one, if I go to the formulas now, Nicole, I got this one, k a to the power of x. You see this one?
Yes.
So
Yes.
now let me write it down to say if I'm given here, just to link you back to that, if I'm given y is equal to k a to the power of x, then they say what? Dy over dx becomes what? Let's take that. It's k a x ln a. Are you seeing that?
Yes.
So I have k a exponent x ln a. So now if I say let's use this here, how can we use it now, Nicole? What do you think? Look at that. Is it possible? Let me take it up
They
again.
talk about the A, so I'm not sure because there's only one number there,
Yes.
and
Now,
then you get your X.
thank you. Now look at this now. Your A here is your 6. You see that?
Okay.
You see
Yes.
that one? That is your A. So if there's K, maybe they could have said 2.6 times, So there is no K in that case.
Yes. Yes.
So now they gave us the 6, but now look at your X. What is the X here? They
It's the
gave
positive.
is a negative 2x this side.
Yes.
So you cannot just use directly now the formula. You see, that's
Yes.
when now you say, okay, since I cannot use, I can then say let this one maybe u is equal to minus 2x, or u is equal to 2x. Let's just use u is equal to 2x. Let's say negative 2x is fine like this.
Okay.
You understand? Then at this moment you're like, since I'm gonna make u is equal to 2x, then I'm forced to use this one now. The moment I say u here, it's the only one I'm gonna make. Then it becomes the chain rule.
Okay.
Because I cannot use, you see, you use the quotient, you use the product rule when you've got two things. For example, you say let u and let v. There will be two of them that you need to make.
Yes.
So if there are
Yes.
two of them, then you cannot use the chain rule. You have to use the product rule or the quotient rule. Because
Okay.
why? Look at this. When you come back to the 2, you have got, you see here, it says v, it's u dv over dx, and then you have got v du over dx. So there must be let u and let v. Are you getting
Yes.
that? But in this case, the moment you have one of them, to say, if I want to solve this, I can only say let u be equal to that. You must know it has to be a chain rule because I'm not going to have any other unknown. So that
Okay.
when I
That
have
makes-
here, I will say du over dx. What would be the answer here?
du over dx will be minus 2.
Minus 2. So that's the first part. I don't have any v. I can't put any v because here my y, what is my y now when I'm solving? So it will be y is equal to what now?
It's going to be 6,
6.
I think.
Yes, 6 to the power what? 6 to the power of u.
Yes.
You see, from what I did here, it means then my y is equal to 6 to the power of u. Then I can use this formula now.
Okay, I see.
You see now? So what
Yes.
is dy over dx of this thing now? I mean
Okay,
dy
so
over du, because it will be du. It will be what? Let's use this formula here as is. So it says if it was k, now remove k from this formula because k you see is appearing. If I take out k, do you see that I'm left with ax?
yes.
So which means it's ax ln a. Are you seeing that?
Yes.
So what about here? What will it be if you have got 6 to the power of
Okay,
u?
so it's going to be 6.
Mm-hmm.
Then you put in your minus 2x.
Yes.
Then it's the ln
Uh-huh.
6.
You understand that? That's
Yes.
where now this whole thing is. So if you have
Okay.
got this, then you pull in together as you said with the chain rule to say dy over dx is equal to dy over du times du over dx. Now this one, you see, it looks a bit simpler, but it was forcing you to do that because
Yes.
it looks like, okay, I'm just differentiating. Where was our question here? It was like you're just differentiating negative 6 to the power 2x. It looks simpler, but it's even more complicated than these two, you see, because
Yes.
of that 2x there. You understand?
Mm.
And then when
Yes.
you continue with that now, Nicole, it will become, now let's pull it all together. It will become what? Dy over du is 6 to the power negative 2x, right? Ln
Yes.
6, and then times, what about du
Minus,
over dx, which is negative?
minus 2.
So the answer then, it becomes minus 2 dot or times 6 to the power negative 2x ln 6. Are you getting that?
Yes.
So now this is what is this one? This is a chain rule, right? I mean
Yes.
that we used. Now look at this question. Now we say how do I know? You ask a question. How will I know when to use what? Look at this question, for example. Here they gave, I think it's here, they were strict. Where is that question? I want to check that question. They were strict to say literally you need to use this. Where is this one? Look at this question. Question 4.2. They say differentiate with respect to x, y is equal to 10x over ln x. And then look, with the aid of a quotient rule.
Yes, I see. So they
So
will
now,
tell you
yes,
most
they
of
will tell you, Nicole, but mainly when you're talking about the quotient rule, always have a fraction mainly also, you see,
Okay.
because that's where it will work, the fraction. And then look at 4.3, differentiate with respect to x, ln that. Now look at this. There are two of them. You have got ln x squared, you can call it your v, I mean your u. You have got ln squared x, you can call it your v. You see,
Yes.
two separate things can become u and v. Then from here, there is no way a chain rule can work, because a chain rule says it's either you have got u, so that you can say dy over du, and then you can say du over dx, you know.
Yes, I
Understand? So
understand.
let's start with this one. Will you want us to look at this one?
Yes, please.
All right. It's still something to do, as you said, with trigonometry. So they are saying here y is equal to what?
10x
Tan x over
over ln x, I
ln
think.
x. Now, I want us to come back to the quotient rule, the way they brought it in here, to see if ever you understand how. Usually, I usually write it the way I understand. Okay, this one, what is it saying? Are you able to interpret it like this quotient rule?
Do I understand it like
Yeah,
that?
do you understand it like that?
No.
Okay, so this is even me, the way they put it like this, it's a bit funny, because here, when they say v of x, the actual thing for v of x is, let's write it the way it's easier from the book's version, you know, the way they always
Yes.
bring it from the book. So let's start there. It says vx of u, so the actual one here is to say dy. I'm just going to cut it now in this way to say dy over dx is equal to, so when they say that Vx of u, so it's V, remember what you'll be having, let me take it from the beginning again. What you'll be having, y is equal to uv, u times v.
Okay.
That's what you're differentiating, right? So dy over dx is equal to, you take the first v, which is v, and then you've got what? You have got du over dx. Are you seeing
Yes.
that?
Yes.
And then minus, I think there, let's come back there. It's minus. If you look at it, it says minus, but it's
Yes.
minus u now. You see, so you come
Yes.
there, it says, okay, it was v. I said du over dx minus u, so it's gonna be what now? Dv
du
over
d.
dx, and then
Okay.
divided by what? By that v squared. Are you with me? So is it
Yes, I'm with
this?
you.
This is the v squared. You see at the bottom. So they put that x thing to confuse you. So I usually ignore that and say, okay, if I forget about these x's, this one. You see, if I forget about these x's here, these x's, you can see it's v u prime. Remember, is du over dx
Yes.
minus u dv over dx over v squared. Are you seeing that? So now,
Mhm.
if you have it, better to write it the way you understand it from the normal books. They usually write it like this. And
Yes.
then from there, we come here now, Nicole, and say, how do you want us to look at this? You're going to then tell us what is your what? Your u, what is your v, you see. So what is our u? Our u is going to be 10x.
Yes.
Now, what is our du over dx?
Du over dx,
For
that
10.
will be, Wes, can you please just go to the formula sheet
Formulas,
again?
yes.
It's going to be sec squared x.
Thank you.
I think.
Please don't
Yes.
cram these things, okay? You don't have to master this. It's just a waste of time because
Yes.
they are there, you know. What about if our v is equal to ln x, and then what is our dv over dx going to be? Again, we go to the formulas. For ln, what would it be? There is our ln. So what is our
Yes.
k? What is our k here? What is our k here? Our k here is simply a 1, you see.
Yes.
So now what will be our dv over dx here?
So it's going to be 1 over x.
Thank you. Just ln x is just 1 over x. Are you with me?
Yes, I'm with you.
Alright, so if I do that, I'm going to have here 1 over x. Are we together then?
Yes,
Then
we are.
let's pull this together into this now formula of ours to say this is equal to v. What is our v?
It's 1, it's ln
Ln
x.
x, we can forget about 1 there. Ln x, and then times du over dx.
Du over dx is 1 over x.
Du over dx, no, it's this one. It was sec squared. Sorry about my
du,
writing.
okay,
Yeah,
yes.
it's my writing there. This is a v. I see it. It's terrible, I know. So that is sec squared, right?
Yes.
X minus, what is our u? We said
1
our
over,
u. Our u was here 10x.
oh, it's tan x,
Yes,
and then
minus
the
10x.
d,
Yes.
yes.
And then what is our dv over dx? It's
That will be
multiplied
1
by
over
1 over x. Please be careful there to put brackets because you see, this is a trigonometry now. If you say 10x
Yes.
times, if you put it times here, it's fine, but it's better to show
To
that
put
this
the
is
bracket.
in a bracket, yes. And then all over, what is our v squared? Which is that
Ln,
ln
yes, ln x
x
squared.
squared. Are you with me then? So
Yes, I'm,
simplifying this is up to you, Nicole. They will just mark you. How many marks was this? This was 3 marks. You see?
yes.
You no longer need to go further here. You can just leave things like this. You know, it's not really a must to say now, is there things that I must write properly? For example, 10x times 1 over x. You prefer to have 1 over x. It's up to you now. You understand?
Yes.
So you just leave it like that. Then they would, because what they are looking for when they 3 marks, you see, they'll just mark this. That's the set part. It takes a lot of marks, but they're just marking 1, 2, 3. Can you believe that?
Yes.
All right. So that was the what? That was when we were using the quotient rule here. All right. Now, what
Okay.
about now if I say let's use the product rule? And I'm saying both the quotient and the product rule. Just remember 2 things, as we always say. How will I pick it up? You will pick it up because you'll have 2 things that are not the same, where it forces you to have a u and to have a v.
Yes.
Even here, On the second one, ln x squared becomes your u, ln squared x becomes your v. You see
Yes.
how this whole thing. So now
Yes.
let's look at this question, for example, to say, actually this question, if I'm not mistaken, Nicole, this is the question that was written just in March, April exams, eh? They brought
Yes.
this, yeah. So let's look at this one. It says y, if you can also write it down there, ln x squared, I think they wrote it like that, and then with what? Times ln squared x. Are you with me?
Yes, I'm with you.
Okay, with the aid of a product rule. Now, what do you think? Now, they told us already, product rule, so you don't have to think much. But even if they didn't tell you, Nicole, if they didn't tell you, you were supposed to use the product rule. You know, why? Because you ask yourself, can I use the chain rule here? You're like, okay, this is my u. Chain rule forces you that it's only u. There is no v. So you're like,
Yes,
okay,
you can't
let
use
me
the
take it
chain
out.
rule.
Then you are forced, you are left with 2. And then it's either you're left with the quotient rule or you're left with the product rule. Now the quotient rule, as you remember, it's over v squared. It must be a fraction.
Yes,
See?
I'm able to see your
All right.
screen.
So what I was saying now, back to what I was saying previously, Nicole, is say if they give you, we are back. Let me erase also here. If you are going to be dealing with the quotient rule, quotient means I must have a fraction. What I'm differentiating. So
Yes.
you have to find yourself having a u and a v, meaning it's a fraction for my dy by dx. If I'm going to use a product rule, it's two things multiplying u times v. If it's a quotient rule, it's u over v.
Yes.
If it's a chain rule, I'm just only dealing with u. There is no v in that.
Yes.
Are you with me there?
Yes,
So,
I'm with you.
all right. So now, if we come back here to say, how do we go about then differentiating this? What do you think? If they told us already the hint, we're going to use a what? They
The
said,
U and the V.
yeah,
The product
the
rule.
product rule. So here they are saying in simple terms, you are going to use y is equal to u dot v. Let me write that differentiation there. It says, remember, I don't want you to cram it, but just come here, just remove this x's, remove this x's, remove this x's, remove it. How will you write it now? It's what? It's u, and then it's what?
Over V.
dv
V, yes.
over
V.
dx. You see that? And then plus
Yes.
what? There is the
It's
v.
going to be
You see the
U.
v? No, that
Well,
one.
V
If it's u
du.
prime, it means it's to u over dx.
Okay.
Okay, let's redo it again together, because I just want you to kind of get it from here. Let's
Okay.
rewrite this. So when you see u, forget about the x. Ux there, actually it means du over dx.
Okay.
But they're saying sorry about that. No, I'm the one who's wrong. Here, v1 is the dy, is the dv over dx, this one. So it's dv over dx. But you're multiplying
Okay.
by what? By u.
By U.
And
Yes,
then
that makes
plus, then because they started with du here, the u prime means it's du over dx. But you must multiply by what?
V.
By v.
Okay.
Are you with me? So just
Yes, I'm with you.
be careful to, they try to twist it around. You end up mixing it to say ux here, you'll call it du over dx times v. And then here, u prime, you call it, you just confuse yourself. But just remember, when they give you a u, remove this x so that you say u instead of saying du over dx, You call
Yes.
it a u, then v prime is the dv over dx. And the u prime is the du over dx.
Okay.
Are you with me? So you can
Yes,
see
I'm
that now if we write this, it's u dv over dx plus v du over dx. If you write it here, it will be, sometimes you can write it on its own, just given uv like this. You say dy over dx is equal to, can you try it again? I start with what?
U. What is yes, U
And then,
dV
thank you.
over dx
Alright, and then plus.
times V.
It's plus. Let's
No,
look at that.
plus
It's
V.
plus. You are adding, right? Plus
Yes.
what?
V.
V.
Then it's D. Yes, du over dx.
Over dx. Are you gonna be able to also look at it if you are given this version?
Yes,
Just
I
give
will be
yourself that
able to
vision.
read
So
that.
you just say, let me forget about their formula. You just look at it to see that it matches instead of maybe you wanted to say times by error, you go to the formula, you remind yourself, oh, it's a plus, even
Yes.
here on the quotient rule, it's a minus in the center. So those are the things that you can now refer to the formula to remind yourself.
Okay.
Then when we're like this, let's come back to this now, Nicole. How do we pull this thing all together? How many marks is 5 marks, eh?
Yes,
So
it's
what do you
fine.
think? We start with the first one. We said our u, we can make our u here, our v that. Am I right?
Okay, sorry, I just want to get another pen. Okay.
Okay.
So, let u,
Let u equal to what?
it's going to
Ln
be,
x squared.
yes, ln x squared.
Now, how will you differentiate ln x squared? What do you think? Remember, these are logs now. With the
Yes,
logs,
doesn't ln become e?
okay, let's go. Oh, sorry, let's come back here. Let's come back here. Let's come back here. There, you are given ln.
Yes, yes.
So it becomes 1 over
1 over x.
1 over x. But now look at this one. We've got a 2 there. So what do you do first? Because the 2 is the one that is kind of tricking everything. So what you do, remember the laws of logarithms? The 2 can drop here
Yes.
first. So you don't have to differentiate first. You have got u is 2 ln x first. So
Yes.
that this becomes your k now. You see now?
Yes, I see.
You see that? So when you do that, you can say du over dx. You see that? Is equal to 2, since
2
here,
over x.
yeah, 2, you are right actually. Let's just write that. 2 over x, that's it. But you see, they
Okay.
tricked you, because if you were not able to take this 2, it was going to make an error for you, because what are we going to do? Because you know that it's 1 over x, but what do I do to my
Yes.
2? I must drop my 2 first using the laws, So there is some mathematical concept you must know before also doing that.
Just a question.
Yes.
So when we work with differentiation and integration, do I just use the formulas they give me?
You just use the formulas, Nicole.
Okay.
They're formulas. Don't go any further, because they already tell you these are the answers. Just master this, and then everything you are given, try to make it fit into this table.
Yes.
Once it fits into the table, then you're gone. But
Okay.
if you fail, for example, you say here I had x squared. No, it's not in the table now. It's not in the table. But when I drop it, it becomes part of the things in the table. Then I can now differentiate from the table. Are you with
Okay.
me?
Yes, I'm
But
with
you
you.
can make your life a little bit hard here, whereby you can do this. Just want to show you how you can make life a bit harder. It's still correct. You are like, okay, I'm given this u is equal to ln. Let me use a different pen here. Because everything you see, it's about how you want to do it. If you say u is equal to ln x squared, you are like, okay, I want to use again a chain rule here, whereby I will say I'll call it w is equal to x squared. You see this?
Yes.
So that you have got u is equal to ln w. You see that? Then I will
Yes.
have du over dw
Yes.
is equal to 1 over x. You see
Yes.
that? And then you're going to say on this one, dw over dx is equal to 2x. You see, I'm using the chain rule now.
Yes.
And then you're going to say now, therefore, dy over du over dx, since I don't have y, it was du. Therefore, du over dx is equal to, it will be the first one, which was dw, is dw over dx times du over dw,
Yes.
so that, remember, this must cancel out, so you have d over dx. So if you look at that, if you continue look at it, what is dw over dx? There it is. It's 2x times, what is du over that?
1 over x.
It's 2. Sorry, this was 2. Sorry, I'm making error now. dw, I was given already. What am I doing? I was given already here, Nicole. Sorry, was it x squared? Oh yeah, it was x squared, right? So
Yes.
which means if it was x squared, it's gonna be 2x. Okay, I see now. Then this one becomes what? 1 over
X.
1 over x. Am I right? And
Yes.
then if we look at this one now, is there no ln here? Why did I not have a ln? I think am I okay? There is a ln w. Okay, there u is equal to ln w. Am I right?
Yes.
And then I said du over dw is equal to what? 1 over x. 1 over
1
x.
over x.
Is this not 1 over x, actually 1 over w? Yeah. Remember, I'm having w there.
Yes.
You see, 1 over w. You see that one? Because I
Yes.
said du over dw, I don't have x, it's 1 over w.
Mm.
Even here, I said w is 2x squared, but this one is correct. We can maintain
Yes.
it like that. So the one that was now coming out funny, it was this part. So let's correct it here. So that, what do I have now? I'm saying du over dx is equal to dw over dx,
Mm-hmm.
which is what? 2x,
2x
times du over dw, which is what?
is 1 over w.
1 over w, which is equal to 2x. Now, what is times 1 over w? And you say w is what?
W equals
X
x
squared. So
squared.
you come here and say 1 over x squared. You see that?
Yes.
So what is the final answer? See, the x cancel the x squared to have 1x, right?
Yes,
So
so
what will
it's
be the
going to
answer?
be 2 over x.
Over x. So you can go through this whole process now, Nicole. This whole process just to get the same answer that we got here.
But it takes a lot of
But it
time.
takes a lot of time, you see. So it's a matter of someone who, between you and someone here, let's say another person thought of option 1 and someone thought of option 2. Do you know what made a person take option 2? It's because they don't know the laws of logarithms, that 2
Yes.
can drop there. So you see that it can make work even more heavy if you are not using also other rules outside
Yes.
the normal differentiation, you know. So
Yes.
you must have your mind ready to say, this I'm differentiating, but there are some rules that I can also use before that so that it can make my life easier.
Yes.
You understand? So even here, you are forced to end up making some errors because you're now using W or other letters. You see, we're already making some errors because you're not used to extra new letters, you know. The mind is mainly used to V and W, you know. I mean V and
Yes.
U. So
Yes, I'm with
I'm
you.
putting a W now. I'm making errors. I'm checking myself. Why is it wrong? But usually try to stick to what you are having.
Okay.
Are you with me? So
Yes, I'm.
we have that. That is the first one for the U. What about this one now? This one now. Let me take this down out. If we are differentiating here, ln squared x, let me write it here. Ln squared x. Now, what is ln squared x? Remember, it's our v.
Yes, it's our
Yeah.
v.
Well, so how do you differentiate that? What do you suggest?
See, this is the one that always confuses me because I'm so used to the square being with the x.
Yes, so now you must always remember these two are not the same. You see, this one is ln x squared.
X
So where
squared.
is the square? It's on x. Here,
Yes.
where is the square? It's on ln. So what they are trying
Yes.
to say now with you, Nicole, they are saying this is same as v is ln x times ln x.
Then x.
You understand?
Yes.
So now, how do you differentiate this now? That they were a bit clever here. How do you differentiate this now? What do you think? It's the same things, but how do you go about? Now, if you ask me what can I have here, I could have used actually the same thing to say back again to the product rule of this thing again. You see,
Yes.
whereby if you don't know the answer, if you are not used, but once you know its answer, it's easy to state the answer because we come back here. You see, it's not in the formulas. You see.
Yes.
So if you come here, you can go back to that's the part now, say, okay, I can use again another product rule within a product rule. So you say this becomes my U, this becomes my V. Are you getting that? So now,
Yes.
if U is equal to ln x, let's do it. What is du over dx here?
Sorry, just let me write it down.
So you're forced to do a little bit of side work again here, but once you know the
Yes.
answer, I'll show you can state it. But I don't like cramming part, you see, because
Yes.
sometimes it needs you to cram. So you can actually do it the long version like this, so that you don't have to go to the exams with some things crammed. I can work it out after all, you know. So let's do it. What is this? Du
It's
over
going
dx.
to be 1 over x.
Thank you. It's 1 over x, right? Now, we know again, so this is 1 over x. The good part is even v will give us the same answer, right? If
Yes.
v is ln x, so what is dv over dx? It will give us what? 1
1
over
over x.
x. Now, we're going to apply the same formula here, this same formula, all right? So while we're watching it, it is going to be, in this case, remember, I'm going to have now here to say dv over, because this was v is equal to this. So
Yes.
dv over dx is equal to, I'm using this formula. It's u dv over dx. So it's u,
Yes.
what is u here?
The u is ln x.
Mm-hmm. And then what is dv over dx?
That's 1 over x.
You see? And then plus, what is my v?
It's ln
Because
x.
I'm here. You see, I'm watching. Are you watching this formula also? We're using
Yes.
that formula. Ln x. And then the next one is du
1
over
over.
dx, 1 over x. You see?
Yes.
So you can use this. And then you're done. After this, you pull it together. How many of these? You see, there are 2 of them. You see?
Yes.
Then you say equal to 2. You can put, because this is 1 over x, you can say 2 over x actually here. Ln x. It's two
Okay.
of this because there is a 1 and a 1. So it's the same thing, eh? So
Yes.
it's 2 over x ln x.
Okay.
All right. So if you're good at it, they allow you straight away from here. They allow you to say, someone comes and say, okay, me, I didn't go through that route. Someone just comes here and say, if you give me y is equal to ln squared x and then dy over dx, I will say 2 over x, because this thing will go down, remember ln, and then you say ln x. If you do
Yes.
this, they'll give you a mark. There's no penalizing. They'll give you a mark if you go
Okay.
straight away. But don't forget, it's not in the formulas, okay? Sometimes, what
Yes.
if in the
Okay.
exam you forget, now you say 2x, or you say, no, it's supposed to be x over 2. You see, now you're changing everything, you know? So it's
Yes.
based on guesswork now in that case. But if you feel like, I know that I know, you just remind yourself, ln
Yes.
become 1 over x. And then these 2 will go to the top. But it
Okay.
needs you to be fresh, just when you're revising, maybe you revise it a day before. When you go to the exam, you can literally state it like that.
Okay.
Are you with me? So when we
Yes,
have
I'm with
when we have
you.
done that, then we can put things here to say what is our dy over dx here. So you have got finalizing of dy over dx is equal to u, and then what was our u, by the way?
Our u was 2 ln x.
Our u was 2 ln x. Thank you. 2 ln x, and then what is
And
our
our
dv?
dv over dx was that 2 over x ln x.
Yes, was 2 over x.
Ln x.
Right? Plus
Then it's plus.
our v was still what? What is our v?
Our v was ln squared x.
Ln squared. What is our du over
And
dx?
it's 2x.
It's
2
2
over
over
x.
x. Yes, you're right there. Then at this stage, as I keep on saying, it's up to you to say, do you want to simplify things further or what? But you can just leave them like that. I've just differentiated. So
Yes.
it's optional for you to say, okay, usually it's fair for me to write maybe here. Look at this one. You see there is this 2 and this 2. Someone can say, because it's 2 and that there is that 2. Someone can say they can multiply, or you can actually remind yourself that this 2, actually this 2 is on top here, remember? So you can take
Yes.
it back to say this was ln x squared. You see how it becomes now?
Yes.
And then that x over 2, you can put it here, like in front here, this x of 2 over x can be here, and then multiplied by ln x. You see, so it's ln x squared, that multiplied by ln x. I'm just rearranging things here.
Yes.
And then even here, plus here now it's 2 over x ln squared x. You see, so the way you're gonna arrange it and everything is up to you.
Yes.
You understand? So, but I'm trying to say, sometimes avoid breaking some logarithm rules here, because you might find yourself breaking some rules and the answer changes. So if you leave it like this, they'll look at the answers there, and just
Okay.
give some mark there. It's much better than to go wrong going down, because the algebra now was taking place whereby you were making errors.
Yes.
Yes. So that is that part now of the product and the quotient rule.
Okay.
All right.
I'm fine with
You're
that.
fine with that one. Okay, so that is the part then that we're looking at. That is the differentiation part and everything. Now, can we then move on to the integration part?
Before we move on, I
Okay.
just want to ask a question.
Yes, no problem.
At 4.4, that's square root of 2 over
Okay,
e.
let's look at that. I think we didn't look into that. Let's look at that. They
I
gave
just
us.
want to see how you do
You
that
do that.
one.
Yes, you're right. At this one, right? Let
Yes.
me erase this. It's this one. Let's just write it down. It's y. Here it's y. Let's just call it y is equal to square root of 2 over what? E to the power
E.
negative x.
Yes.
Right. So here, what we are doing, again, we are using the laws of exponents. It's exponents here. So what you just
Yes.
simply do, take this to the top. So you simply have
Yes.
got y is equal to square root of 2 e to the power
E.
x.
Yes.
And then if you say dy over dx is equal to, now remember square root of 2 remains square root of 2. Now
Yes.
you can't differentiate that. This symbol becomes e to the power x. E to the power x always remains e to the power of x. Let me check the formulas here. You see, we don't have e. You don't have an e. But e, if you check your book, if you differentiate e to the power of x, even if you integrate e to the power of x, integral of e to the power of x is simple e to the power of x plus c.
Yes.
You understand? Remember, integration and differentiation are the opposite. So it just maintains that.
Okay.
The main thing, let's come back. Let me show you why it's like that also. Just maybe you can say, but where are you getting this from? Let's look at the way. If you give me here, let's say, let's take this formula here. Because what we are differentiating, we are dealing with this. Right?
Yes.
So let's take this to say k a to the power of x. This one. Let me write it down. K a to the power of x. Remember, when you differentiate it, it becomes what? K a to the power of x ln a, right? You see,
Yes.
I didn't cram these, Nicole. I also use it like you do. I check them. I don't want to go with my mind full of this stuff, you know.
Yes.
So I'm also having to check the formulas every time. I have to rely on the formulas. So look
Yes.
at this. Remember, we are saying if you are given here this y, then this is dy over dx. Are you with me?
Yes.
So if I
Yes, I'm
give
with
you now and say y is equal to e to the power of x. Remember, there is a 1 here.
Yes.
So k is 1. So it will be dy over dx is equal to, so what we do, our k is what? It's 1.
1.
And then a to the power of x is e to the power of x. You see that?
Yes.
And then it's ln a. What is our a here?
Our A is square root of 2.
Square root of, no, on this one. We're just working on this one now. To say it was 1 and ex, right?
Yes.
So
1
our
and 2.
e is this one. You see, like our k, our k is 1. Our e is
Is
a.
A.
Our x is x. So that's why here ln a is ln e.
Okay.
You understand? And you know what
Yes.
is ln e? There is a base of e. E of e is 1. Hence,
Yes.
this thing becomes e to the power of x.
Yes.
You see, hence you just don't have to go through the root and say, what is this? It's just dy over dx is root 2 e to the power of x, because it will be
Okay.
ln e, which is 1. You know?
Okay, that makes sense.
Yeah,
Thank
yeah.
you.
I was just trying to justify why it becomes like that. You know.
Yes.
Yes, and then so that was that part here, and I didn't do this side. We had 1 here, but I wanted to check on integration. You had asked also something on question. I think it was this question. Do you think you still need some clarity on the logs here, on the what do you call this one, trigonometry?
No, that I just will go practice.
Practice on those back ones, because
Yes.
what happens to sine 2x, as I remember telling you, this one now, don't forget, you first take the 2 out, it's 2, then sine becomes what? Cos, and
Cos.
then, but don't forget you maintain your 2x, you know.
Yes.
You understand? And then
Yes.
this one, you need to take it to the top from 3 to the power negative 5x, it will be 3 to the power 5x, but don't forget
Yes.
3 to the power of 5x, you need to differentiate that, which is your u. This becomes your u. So you're differentiating 3 to the power u, then you use the chain rule here.
Yes.
You know, so those are the things that, and then pi, there's 0 here. The moment they give you this is a 0, you know.
Yes, because they don't
Have x,
you
you
need
know.
to differentiate in terms of X.
Yes, you understand. So that is that
Yes.
part. I don't know whether it makes sense in that part. So which means on that we can rest the case. Am I right?
Yes.
Now when we come back to this one for, okay, another thing, you are good about this one to say, because this is the application of differentiation, to say Determine with the aid of differentiation the x coordinates of the point of inflection. We are fine with
Yes,
that.
no, that I'm fine
Thank you.
with. That I can
That one
do.
is fine. And then the limits also is something that you have to just check out, right?
Yes, the limits is
Yeah.
fine.
So here, which area will you want us to start with, especially when it comes to
Okay,
integration?
so with the integration, it's the first time I'm doing it because I didn't do it in matric.
Okay.
So I just want you to go through the basics with me and then I'll just go practice it out.
Okay. All right. Now, when you're talking about, let me just look at this now. When you're talking about integration, now, integration, remember, is the opposite of what? Of differentiation.
Differentiation.
Differentiation. So now I will come again and say, whenever you are integrating, please rely back here. We are here now. Let me make it small. This is you now on integration, right?
Okay.
So what are they saying? Let me take the first one here to say, if I give you y is equal to a to the power of x to the power of n. Now, when they do that, now when you're integrating, you say integral of a to the power of what?
X.
X n. But now, to show that you are integrating, you are saying this is in respect with x. You say dx.
Okay.
Meaning, I'm different, just like you are differentiating. You are saying dy over dx, meaning whatever I'm doing, it is with respect to x. So even
Yes.
here, when you're integrating, you put that dx because it's important to say I'm integrating with respect to x,
To
meaning
X.
focus on x there.
Okay.
Because someone can put a here, it means don't forget about x. Now focus on what? On a, you see. So
Yes.
that is that thing. So if I say dx equal to, what does it mean? This n now, this n equal, it plays two roles. So the a is always, you can actually write this with the a. A is same as saying take it out. You can have a outside, and then you get integral of x to the power of n dx. A doesn't play any role.
Okay.
It's just a number. It's your k,
Yes.
Then if you continue here, it's your a. Now, as I said, this n plays a two role. So you are going to say what? It will be x. You add a 1 there, which is n plus 1.
Yes.
And then at the bottom, you divide everything by the same thing that you did, which is
N plus
n
1.
plus 1. Are
Okay.
you with me? Let's pull out
Yes, I'm
let's
with
pull out
you.
something simpler, as we say the basics here. If I say let's integrate, for example, 2x squared dx. Okay, I forgot something here. What did I forget? Always say plus c, constant.
Plus. Okay, what is the C?
What is the c? Okay, I'll make an example here. I'll show you something. Let's look at this. If I say 2x squared dx, differentiate this for me. What will it, integrate this for me. What will it become?
Okay, so it will be 2,
2.
your integration sign. What do they call it?
Yes, integration sign, integral sign.
Okay,
It's
yes.
integral. Yes.
Yes. Then it's going to be X,
Mm-hmm.
2 plus 1.
Okay, so now this is the thing. First of all, when you put the 2 outside, maintain that you haven't started differentiating, integrating.
Oh,
Yeah, you haven't started. You're just showing us that this 2 does not play a role.
okay.
Then the moment you use the formula or the method of integration, then it falls away. You'll say 2, you don't put that sign again.
Okay.
Right? So when you say 2, then you say times x, you see? X,
Yes.
it falls away. Then what do I have?
2 plus
2
1.
plus 1, because I can't put that sign anymore because I'm using the formula now. You see?
Yes.
And then
Divided by 2 plus 1.
divided by 2 plus 1. Then when you simplify, it will be 2x to the power of what?
3.
Over what? Over 3.
Over
Yeah, so
3.
it's
Yes.
up to you. You can even say 2 over 3 to the power x cubed. Right. Now,
Okay.
as a test, as a reminder of the test, if I'm given this y is equal to 2 over 3x cubed, and then I say, Nicole, let's find dy over dx. What will this dy over dx become?
Dy over dx.
Of this thing.
So you will take the 3
Mm-hmm.
and you multiply it with the 2 over 3.
Uh-huh.
Then you take the 3 minus
Which is
1.
what? Which is 2. So if you
Yes.
cancel this, it will become what? 2x
2x.
squared. You see,
Yes.
where does it take us? Back to that. You understand?
Yes.
So it's just the opposite. Now you ask me a question to say, what is C? Let me show you
Yes.
now the part for C, where C comes into play. I'm going to do the same thing. Let's integrate 2x squared plus 3. and you put a bracket, and then I'll say with respect to x.
Okay.
All right, equal to, let's do that. What did you have for me? Remember, you are doing them one step at a time. It's just like dy over dx. Remember, you do for 2x squared, you do for 3. So always picture the same thing you're doing for differentiation is still the same thing here. So here you focus on 2 to the power of 2x. So you are going to have your 2, right? And then x, 2 plus 1 over 2 plus 1. That's the first one, right? And then plus, what will you have? What will you have on this other one?
Plus 3.
3. Now, because we're integrating now, Nicole, this 3 then becomes an x.
Does it become an x?
Okay. Yes, because it will become, we'll show you when we go back to the part, right, of okay, integration now. And then we're going to say plus c. Are you getting that? Then yes, when I continue here, what will I have here? It will be same thing that we did, which was 2 over 3 x cubed plus 3x. Are you getting that? Now, yes, it's still not doing me what I wanted, but let's start from this. I want to show you the c. I didn't get what I wanted. Let's do this. If I give you 2x squared plus 3, I call this y is equal to. Can you find me dy over dx of this? I think it will work here. Yeah, dy over dx. It will become what?
Okay, so it will become the one we did the last time.
Yeah, it will become like here, because I dropped the 2. 2 times 2 yes, is 4x. Yes. This is 4x, right? Plus what?
Yes.
Plus 0.
Plus 3. Plus 0. Oh, remember, it's a 0 because it's a constant.
It's a constant. When I'm finding dy over dx, it's plus 0, right? Yes. Now, if I say, remember, differentiation is the opposite of what?
Integration.
Of integration. If I say, okay, since this was the answer, and you saw that, like here, I think yeah, the method will work. If I take this one now, Nicole, and say you are given y is equal to 2 over 3x cubed plus 3x, right? And then I say let's differentiate this dy over dx. If you still remember, you drop the 3 there, it will be 2x squared plus 3, right? Now, yes, look, this takes us back because these two work hand in hand, right? But yes, now I want us to go back to this one here. I want us to go to this one from this one now. Meaning, if I say integral of 4x plus 0 dx, because this is dy over dx, I want us to take me back to that y. You understand?
Okay.
So what will it be? Let's apply the rules. It will become what?
Can we put the 4 yes, in the front?
Yeah, 4 in front, but you don't have to keep on, you know it already, 4. So I'll put x. Yes. What do I put here?
It's going to be 1 plus 1.
Thank you. Over?
1 plus 1, so
right,
2.
Plus, now, look, I must differentiate 0. And 0 is 0, you see? So I still yes, get 0x if ever I'm to do anything out of it, and it will become 0. So now if I continue here, it will become what? 4x. It's 4x squared. You see that?
Yes.
Over 2.
Over 2.
So the answer is what? 2x squared, right?
Yes.
But look, the 3 didn't come out. You see that the 3 was lost. It ended up becoming a 0. Hence, they yes, say, when you say plus c here, you are representing that lost 3.
Okay.
Because that 3 is a constant. So when you're saying, every time you're differentiating, you say plus c, you are trying to say sometimes the 3 can be lost along the way. So in this case, yes, 3 was lost, and our constant was what? By saying plus c, we are trying to say there might be a number which was lost. That's yes, why we represent it by saying plus 3. Are you getting that? So whenever you're integrating, when you just say plus c, you're just trying to say there are some constants that are lost. It mustn't be having x, it's just numbers, okay? So if those numbers are lost, you just, in integral, respect it by saying plus c. So anything you do from here, I must just say plus c. Any integration I do, you come here plus. Everything you do, always say plus what? Plus c. Are you with me?
Yes, I'm with you.
All right. So now, if we come back to a little bit of a practical thing of integration, for example, again, this is heavy on your formulas. Are you with me? it
Yes.
works on your formulas. Okay, we'll do this. You can even try. Let me see one here. I think there's, okay, I wanted something quicker. Let me see. Okay, I think it's here actually. No, here's my page. I'm looking for the other one. All right, we can even use this one. It's the 7 marks here, right?
Yes.
If they are saying, if in here, all of these, you see, it's integration here, all right?
Yes.
So if I'm to say, let's integrate this, is 3 over cosec 4x minus that, right? But don't forget, you must do it one thing at a time. Are you with me?
Yes.
So now let's start with this one to say, if I'm to integrate the first one, 3 over what?
Cosec of 4x
Cosec of 4x, right? And then remember, it's with respect to what? Dx.
to dx.
So now, again, it's a what? It's a fraction. You don't do a fraction. What must you do? Take it to the top.
To the normal
Yeah.
form,
So
to
it will
standard
become what?
form.
It will be integral of 3 what? Sine
3 sine
4x
4x
of dx.
dx.
Right. Then you go to your what? You got your formulas. It's always rely on your formulas. Right. There is your what? There we are here. Sine. Are you
Yes.
seeing that?
Oh wow. Okay.
So all of them. Remember now. The thing is, what I want to bring to your attention is all of them. They have the what? All of them. They have
The
the
dx.
formulas. Don't forget. They have the formulas.
Yes.
Right. So whenever you're doing it, always rely on the what?
On the
On the
formula.
formulas. Don't just say,
Okay.
I'm stranded. Go back to the formulas. Now, here, what are we having? We are having, where is that one? We are having sine. So now,
Yes.
look at this now. If I'm to do it, it is equal to 3. Remember, 3 is outside already. So it's
Yes.
3. Now, the one that they didn't give is that I must, in a way, work on that 4x. Because if I
Okay.
was doing this, just to show you this, if I say let's integrate 3, let me write in white. If I say let's integrate 3 sin x, what we're going to have from that formula? It was equal to, let's check the formulas. The formulas are saying it's going to be what? Negative what? Cos x
Cos
plus c.
x plus
So let's
c.
write that. If I was integrating this, okay, I was going to be negative 3. Remember, the 3 is outside. And then it's
Yes.
cos x. Don't forget, plus what? Plus c.
C.
That was what I was going to get. But the challenge is I don't have an x. What do I have? I have a 4x.
4x.
Are you with me? Then
Yes.
this 4x, in a way, it goes as a fraction. It's over 4, that 4.
Okay.
Because I'm integrating. So it's minus, it will be minus 3 cos 4x. But don't forget, this one comes as a fraction here.
Okay.
Are you with me? So that becomes then
Yes,
the
I'm with
answer.
you.
So don't put it in front to say 3 times 4, like different integration. I mean differentiation
Yes.
whereby it's 4 times 3. No, this time it's 4 over 3. And then
Okay.
cos
That makes sense.
4x. So which means
Yes.
I can bring all of them. If I say to you, let's integrate 10 6x. Or let's actually make it like this, 10 bx. Where b can be any number, right? In terms of dx.
Okay.
You go back here and say, okay, on the formulas, what is 10? 10 is ln sec x. You see that?
Yes.
So you're going to say, okay, 10 is ln sec x. So it's ln sec x plus c. But don't forget over what? Over b on this.
Yes.
Over b, but c is out. It's ln sec x over b plus c. This
Yes.
b is at the bottom, this b. Are you with me?
Okay. Yes. That makes
Does that
sense.
make
Yes,
sense?
I'm with
So
you.
same thing if it was cos x. Now cos becomes sin.
That.
Sorry, I forgot the b here. Don't forget the b.
Yes.
Sorry.
It needs to
So
be
it's
b there
sin
as well.
bx over, what do I have?
B.
B. Thank you. Plus what? Plus c.
C.
Because cos is cos here becomes sin x. You see.
Yes.
So those are the things that you must just remember all together. So now
Okay.
let's continue with this one here. I wanted to bring in also this one here. So that was one. What about this one? If you're now working on this, it says minus 6. Let's work on that also as separate. It's minus, we're integrating minus 6 dot 3 to the power of 2x.
2x.
Always remember this, dx. Whenever you
Yes.
are doing this, the numbers must go out. Just remember that.
Yes.
So this is simple as this minus 6 is out there. Are you with me? You don't have to
Yes,
put
I'm with
in,
you.
you don't have to worry with this minus 6. Actually, what you are worrying about is 3 to the power of what?
2x.
2x of dx. Are
Yes.
you with me? Then,
Yes,
where do
I'm
we
with you.
go? We go to the
Yes,
formulas.
I'm with you.
We go to the formulas here and say which one looks the same. Is this one here. You see that? Because it's
Yes.
k a to the power of x dx. So what are they saying? If it's a to the power of x, so it's k is on top. That is that minus 6 is on top. So
Yes.
you focus on ax. So it's ax over ln a. You
Okay.
see? So if you
Plus
come
c.
here, let me I think it's here. So here it will be equal to minus 6. Now let's actually take that formula. If you're integrating k a to the power of x, it was equal to k a to the power of x over what?
Ln a.
So can you apply it here? What will it be?
So if we apply it, it will be 3
Mm-hmm.
2x.
It will be dot 3
Yes, dot 3
2x uh-huh,
over ln
over ln
minus 6.
of a ln min of that remember 6 is out of a ln 3. Focus,
Over ln 3.
yes,
Okay,
it's
yes.
the 3.
3 is the a.
Remember 3 is the a, you understand? But now look at this, Nicole. In as much as you did that, it's still fine, but don't forget your 2x here, your 2x. Remember that it's a 2, it's not just x.
Yes.
See here, it's not just x, it's a 2.
Yes.
That 2, if you had to remind yourself, if I'm saying y is equal to 2x, when I differentiate this, it's become what? Dy over dx is what? Is
dy over
is
d.
2.
It's 2. Yes.
Remember, it's 2. So this 2, because you are integrating, is at the bottom here. Put it at the bottom now.
Okay.
Because you must say, I know the derivative of it is 2x, so it must come down there.
Okay.
So that now this becomes now the final answer, whereby you are saying 2 into that is minus 3. Are you seeing that? So it's
Yes.
negative 3 times 3 to the power of 2x over ln 3. So what am I saying? I'm saying if you are integrating, the formula will tell you that integral of k to the power of ax dx is equal to k ax over ln a, right? But if I
Yes.
say
Plus
integral
c.
of k a to the power, let's say mx, where m is any number, dx, you see that? So I
Yes.
will say what? K ax over m ln a.
Okay, yes, that makes
You
sense.
understand? So don't forget that m, it must come down there.
Okay, do we need to add the plus c?
Yes, yes, definitely. Everything is plus c. So here on this question, since it was going all once, you will be writing all the answers and then you just say plus c.
Okay.
You understand? So what about this one? Let's try this one. 7e to the power of 3x.
7e to the power 3.
We're supposed to integrate 7e to the power of 3x. And then you say dx. Every time you say plus c. But it's just that we're doing it individually. So
Yes.
what do you think? 7 is already out. You take the 7 out. So in actual
Yes.
fact, you're integrating e to the power of what? 3x. Now,
3x.
be careful of that 3, Nicole, because the formula does not give you what? The formula does not give you the 3. It just gives you this. You see this?
Yes.
Are you with me? So now,
Yes,
let's
I'm with
let's
you.
use, this is what way we are. The one that I marked yellow. This is where we are here.
Yes.
Right? So let's use it. We know that when we're integrating here, it is dx, of course. So it is equal to 7. What must I write?
Then it's going to be e
Mm-hmm.
3x
3x over
over 3
over 3. Thank you.
times
Mm-hmm.
ln
Ln.
e.
Thank you. And you must remember, what is ln e? E of e is
It's
simple
1.
1. So this answer is simple 7e 3x over what? Over
1.
3.
Well, over 3,
Over
yes.
3. You understand? So that is then the answer there.
Okay, that's
You
easy.
understand? Then let's look at
Yes.
the other ones. What about this one? Very interesting, this one. Minus pi over x. Right.
Oh,
So let's look at that to say if you are integrating minus pi over x with respect to dx. Right. Then you remind yourself to say pi is just a number, remember. And this
yes.
negative is a number. So this is same as saying minus pi. What you're working on is 1 over x dx. Just remember that.
Okay.
Because that is just numbers and a sign. So the question is, you come here, how do I differentiate that? You come here to say, it's there. It's there. There it is. Here.
Yes.
You see that? A over x. You see?
Yes.
So when you differentiate a over x, what does it become? A
Um.
ln x plus
Yes.
c. See that? This one.
Yes.
So here, what do you think it will give us? It's supposed to be
Okay. So it will be minus pi.
mm-hmm.
Then it's going to be 1 over x times 1 over x.
1 over x.
Yes.
Mm-hmm.
Len.
Ln. Okay,
I
let
think it's
me let
in one.
me I think let me just before we do that, let me take this down. Let me write that that part here. I think I need
Formula.
to write, yeah, the formula. There's this one, a over x here. Let's write it down to say if it was integral of a over x dx is equal to, and then what you have got a ln x plus c. Let me check that. Which is a, you see that one, a ln x plus c. So
Yes.
this one, this is what we're having here. So now, if we are to match, remember the aim is to just match, follow it as it is happening. So what are you gonna have here?
So it's yes. 1 over x len.
So now you see we don't have 1 over a. If it was 1 over x, so this one, it says here, look at this. Let me just make it like this. Let me take this pi negative out and put the pi back here like this. You see, so
Okay.
that our a is our pi,
Okay.
and then our x is that. So the answer symbol
Yes.
becomes what? Minus a, which is our pi. You see that?
Minus pi.
And then
Yes.
what? That becomes
Len.
ln what? Ln x
Len
plus
x.
c. That was the answer.
Yes. Oh, is that all?
Yes. You see?
Okay.
So because you just need to match apples with apples. The pi is the a, the x is the x. It's just that the negative was the one that was outside. I just take it out, you know.
Yes.
So it's simple actually. This is simple a over x, which is pi over x. So if it's
Yes.
a, therefore it's our pi ln x. Are
Okay.
you getting that one? And
Yes,
then
I understand.
if we're given this one now, look at this. If you're given pi over 5 sec pi x 10 uh, 10 pi x, let me do that to say they wanted me to differentiate pi over 5. Let's write that down. Pi over 5 sec pi x, and then what?
10x.
10 pi
Pi.
x. Right. And then we are integrating that with respect to dx.
Dx.
So you put that, you charge it one thing, dx. Yeah, it's fine though to put it, and dx. Now, you see, when you see these two things, obviously they're trying to confuse you, meaning sec 10. You must try to make it first, simplify it further, so that you can make it, because you can't work out things that are multiplying. If you go back to here, let's go to the formulas. Nicole was, whenever you are now, you know, you are working on this, you need to, in a way, uh, find the formulas, you know. See, this is the formulas. Come back to the formulas and ask yourself, do I have that? Look at this here. You see, you have got sin, cos, tan, sec. Do you see that?
Yes.
I don't have this. I don't have this.
Yes.
But now, look what is interesting. Let's go here on the derivative. Look at this though. If I give you the derivative, that's where now they're trying to play with your mind here. Look at the derivative. There is a sec 10.
Yes.
You see? So meaning, let's play around this. Remember, what is integral? Integral means you are going this direction.
Yes.
So which means if you give me here sec x 10x becomes what? Sec x.
Yes.
So if you give me here sec pi x 10 pi x, if I go backwards it will become what? Sec what?
Sec pi x.
Pi x. You understand? So that's what they just
Yes.
did here. They just did here. to say sec x pi x that. And then remember, pi over 5 is just a number. So you're going to
Yes.
just recognize that this is pi over 5, and then you write what? Sec pi
Sec pi
x.
x.
That was just that.
Is that all?
That's all. Plus C,
Okay.
because that is what goes back. Remember, I said you go back. When you're going back, it means if I'm integrating this, I'll go to that. If I'm integrating this, I'll go to that. For
Yes.
example, let's make an example. One of the examples that is already given. If I integrate here cos x, it must give me what?
Sin
So now, look at
pi.
this. There it is. If I do cos, it becomes sin. It works like that,
Yes.
right? If you integrate sec squared here, it become what? 10x.
10x.
Now, just that they didn't have sec squared here. And then if I integrate, I want to say this one. If I integrate 1 over x, see there, k over x, there it is. This is the one that they have here.
Yes.
You understand? It's
Yes, I
a
understand.
x ln x, but name is k ln x. So it's just
Yes.
one of the things that they're just toying you around with. All right.
So I just want to ask that pi over 5, didn't we need to integrate that as well, or just
Okay.
does it stay in the number?
Now, this pi over 5, remember pi over 5 is just a number. It doesn't have x. So, if you
Okay.
were doing it, you were supposed to say, actually, this, you are allowed to remove it here and have it outside as pi over 5.
Okay.
And then the only thing that is relevant is this because it's got x. You
Yes.
understand? And remember, it's multiplied. So, this is as good as someone saying, integrate for me 410x. You know? And then
Yes.
someone says integrate for me pi 10x. You see,
Yes.
what you do to 4 is what you do to pi because they are all
Okay.
just numbers.
Okay.
You understand me there?
Yes, I
Yeah.
understand. Thank
So
you.
yeah, that was that. And